Okay, now we're going to simplify radicals that are part of fractions. Here is my big tip. Simplify the radical first before you reduce the fraction, because you might end up having to reduce the fraction twice. So for 3 square root 8 all over 12, notice you could simplify the 3 over 12, but I'm going to have you hold off and let's simplify the radical first. So 8 is the same thing as 4 times 2. And now look at the square root of 4 is 2, so a 2 comes out. So now 3 times 2 is 6 root 2 all over 12. And now look at 6 goes into 6 once, 6 goes into 12 twice for an answer of 2 root 2. But if you would have simplified at the beginning, you just would have simplified the denominator twice. So this answer right here simplifies to root 2 over 2. All right, now you've got a cube root. So now what you're looking for is perfect cubes. Well, if you look at our list, 2 cubed is equal to 8, and we know that 8 times 3 is 24. So we're going to simplify that first. 8 times 24, and all of that is over 10. Well, the cube root of 8 is 2. So now we have 10 times the cube root of, 24 is 8 times 3. So now we have a cube root of 3, and all of that is over 10. Now the 10's cancel. So this answer right here, simplified, is just 1 times, and the 1 you can leave invisible, 1 times the cube root of 3. That's what that simplifies to. All right, now what happens when there's a radical in the denominator? Well, imperfect squares are called irrational numbers. And to have a fraction, you cannot keep an irrational number in the denominator. So we're going to do what's called rationalizing the denominator. We're going to make the denominator, turn the denominator into a reasonable number. Well, the only way to change a fraction is to multiply it by 1. So if I want to change the look of 1/2, if I multiply the denominator and the numerator each by 3, now 1/2 I can rewrite as 3/6. Notice 3 is still half of 6. I haven't changed the value. So all I'm doing is multiplying a fraction by 1. Well, that's what we're going to do with denominators, but to get rid of a radical, whatever the radical is, you multiply it by itself. But if you do that to the denominator, remember, because we can only multiply by 1, well, root 2 times root 2 is root 4. The square root of 4 is 2. So anytime you multiply a radical times itself, the number underneath comes out. So now we have a 2 in the denominator. And then 1 times root 2 is root 2. So this right here is a rational number that we can deal with. All right? So now, before you get too eager to do this, I'm going to show you a trick, because sometimes those numbers can get big. Let's go ahead and rewrite 2 root 5. Well, root 10 is the same thing as root 2 times root 5. And now look at the root 5's cancel. So now you have 2 over root 2, and now we're just going to multiply the numerator and the denominator by root 2. These two multiply to be 2, and now you have 2 times root 2, which is 2 root 2, and that cancels. So 2 root 5 all over 10 simplifies to just end up being square root of 2. All right, in the next video, we'll work on when the denominators have expressions.